Welcome back, grade 9s. We are looking at your constant ratio number patterns. Now, those are the ones where we are constantly multiplying or dividing by something. And you will see that the general formula here looks a bit different. We've got Tn is equal to A r to the power n minus 1. The n minus 1 is always part of a formula. A will be replaced by your first term, and R will be replaced by your constant ratio. So what you are multiplying or dividing by the whole time. And I've even told you how to find it. To find your constant ratio, we just divide the next term by the previous term. So the second term by the first term, or the third term by the second term, or the fourth term by the third term, and so forth. They should all give you the same answer. That is what makes it a constant ratio number pattern. So again, if we look at our first example, I'm going to write them out here a bit bigger, just so we can have a look. If you tried to involve the constant difference number pattern here, you will not find a constant difference. 3 to 6, we are adding 3. 6 to 12, we are adding 6. And 12 to 24, we are adding 12. So firstly, that eliminates the constant difference number pattern. Then the next type we are going to look for is constant ratio. Can I see that I'm either multiplying or dividing by the same number? And hopefully you can see that 3 times 2 is going to give you 6. 6 times 2 is going to give you 12. And 12 times 2 is going to give you 24. So there we've already identified our constant ratio. You can also find it, if I get rid of this, like I said, by dividing the previous term or the next term by the previous term. So 6 divided by 3 gives us 2. You could have done 12 divided by 6 gives you 2. Or you could have done 24 divided by 12, also gives you 2. As long as they all give you the same answers, so the following term divided by the previous one, they should all give you the same answer. That will be your ratio. And that is the one part we need. And the other part we need is our first term, and we've got that. That's 3. So we can in actual fact get rid of this, and we can jump straight into answering the questions here. Question A asks us for a general term. So Tn, we've got A is 3. A is my first term. And R we just had as 2. We are multiplying by 2. And n minus 1 is just part of your formula. And that's all how it stays. Please do not go and multiply the 3 and the 2 or anything like that. Think of your exponential laws. They are not the same basis, so we can't multiply them. Okay. Now with that out the way, question B and C are very similar. They're asking you the 7th and the 20th term. With constant ratio number patterns, we do not tend to ask you to work backwards, as it is a bit more complicated to find an exponent when you don't know what the exponent is. Okay, so let's look at B and C. For question B, we just want to know what the 7th term is. So I'm going to leave everything as it is, except I'm going to put a 7 in the place of n. And we can type that entire thing on the calculator. Please make sure to use your brackets properly. And make sure that your minus 1 is still in your exponent. And that's going to be 192. So that means if I continued with this number pattern and I multiplied by 2 consistently, I'm going to end up by the 7th term, it would be 192. And then for question C, same thing, but it's going to be the 20th term. So again, everything stays the same, except we are changing our n to 20, and I can do that quite quickly here, and that's going to end up being 1,572,864. See, 1,572,864 if we consistently just multiply by 2. Okay, and we can easily check that. The multiplication ones aren't that difficult to check. If I start by 3 and I multiply the answer by 2, it gives me 6, then 12, then 24. So that's the 4th term, 5th term, 6th term, 7th term. Makes sense. 192. 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20th term. And that also works out perfectly fine. Okay. So that was just the first one. Let's have a look at the second one. Now here we aren't asking much of you, we're just asking for the general term. We've got 30, we've got 10, we've got 10 over 3, we've got 10 over 9, and we're asking you to determine the general term. So the first thing you are going to do is first determine the ratio. And you can do that by using any of them. So I can use any two terms that follow on each other. So I can use the 30 and the 10, I can use the 10 and the 10 over 3, I can use the 10 over 3 and the 10 over 9, it doesn't matter. I'm going to stick with the simplest ones, and I'm going to use the 10 and divide it by its previous term, and that will simplify down to a third. Now multiplying by a third is the same as dividing by 3, which you should have picked up here. We are just dividing by 3 every time. Hey, if you did 10 over 3 divided by 10, let's see, 10 over 3 divided by 10, it would have also given you a third. Or if you did 10 over 9 divided by 10 over 3, it would have also given you a third, which just confirms that our ratio is correct, and it is a constant ratio number pattern. That means my general term is again going to be my first term, which is 30, times my ratio, which is a third, to the power n minus 1. That's all that there is to it. As always, my suggestion will be to test it. So I'm going to take my answer, and I'm going to plug 3 into it as an example. And that gave me back the third term, 10 over 3. I can do the same with the fourth term. And that gave me 10 over 9, which confirms that I have the correct general solution. Again, 30 and the third, they are not the same basis, so you can't do anything to it. Leave it as it is. Okay, that's where this one is going to be a bit different. Let's grab it, move it with us, and see. For each of the following number patterns, write down the constant ratio, the next 3 terms, determine the nth term and the 10th term. So you'll see again with the constant ratio number pattern, we're not going to ask you to work backwards. We're not going to tell you that term 2 is 16 or which term is equal to 16. Right, so the first thing is we need to determine our ratio. So let's have a look. We can see already here, this is just dividing by 2 every time. Hopefully you can see that. But with constant ratio, we never work with division. We actually only work with multiplication. So we're not going to say divided by 2. We are going to say that it's the same as multiplying by a half. But again, it's much easier just to use any 2 consecutive terms and divide them. Let's use the last 2. 4 over 8. And that's going to simplify to a half. And we can test the rest if you want to. You can go 8 over 16 is also a half, and 16 over 32 is also a half. So that is my constant ratio. Write down the next three terms. Okay, we were up to the fourth term. The fifth term, dividing by 2 still, it's going to give me 2. Dividing 2 by 2 is going to give me 1. And dividing 1 by 2 is going to give me a half. Okay, that's also something you will pick up with a constant ratio number pattern. They will never go from positive to negative. They're not going to change signs. So this will get infinitely smaller, will become a smaller and smaller fraction, but it's never going to turn negative. Okay. Then they asked us to determine the nth term. I'm going to do it on the side here. Tn, we know we need to put down the first term, so that's 32. We know our ratio is a half to the power n minus 1. Again, never a bad idea to go and test it. 32 times 1 over 2, all to the power, let's do the third term, so 3 minus 1, and that spits out 8, and that works. Now I'm going to come back to this. I'm going to leave some space underneath it, because this is one of the rare occasions where you can actually do something to it, and not just leave it as it is. You can simplify this slightly. Okay, but before we get there, let's finish the fourth question. The 10th term, again, we are just going to replace the n by 10. And we'll see that the 10th term is 1 over 16. So like I said, it's never going to go negative. It's going to turn infinitely smaller and smaller. So we can even check the 1000th term. Well, that didn't work out as expected. That is the calculator now just simplifying it and rounding it for us. Let's check the 100th term. It's going to give you a very big, or actually a very small decimal. It is 0.28 zeros, then 5048, and so forth. Okay, let's go a bit closer. Let's go to the 20th term. As you can see, the fraction just gets smaller and smaller, but it's never going to turn negative. Okay, now let's have a look here. This is not necessarily in exams, but it can explain some things later on, because we're actually just going to use our exponential laws here. Okay, we know that from exponential laws, we can only multiply bases that are the same, but I can write 52 as a base of 2. And that is 2 to the power 5. And I can also write a half as a base of 2. 2 to the negative 1 is a half to the power n minus 1. Okay, then using our third law, this power needs to be distributed here. So that means we actually have 2 to the power 5 times 2 to the power negative n plus 1. And then we are actually multiplying the same bases. So we can add the exponents. So this would be the same as 2 to a negative n plus 6. And those would actually be equivalent forms. We can go and test it. 2 to the power negative n plus 6. If we do the first term, gives us 32. Second term, 16. Third term, 8. Fourth term, 4. And there you can see. Now it doesn't really look like a constant ratio because you can't see your first term or your ratio. It's been simplified just using exponential laws. And we're going to use this, what you learned in the constant ratio now, we're going to use in exercise 3. and we're going to chat about the last type of number patterns in the last video for this chapter.